I am Arjun. In this session, we'll see how to solve the problems on harmonic analysis. We'll use ANSYS techniques. So the problem given is conduct a harmonic force or response test by applying a cyclic load at the free end of the beam. The frequency of the load will be varying from 0 to 100 Hz. And the given Young's modulus is 200 GPa, weight density is 7800 kg per meter cube, and Poisson's ratio is 0.3 with a span length of 1000 mm, and cross section of the beam is 10 mm into 10 mm. Okay, now we'll see how to solve the problem using ANSYS, and I'm using ANSYS 14.0. So now I'll go to preferences, structural, okay, preprocessor, element type, add. So I will select beam element for this, click on OK. Okay, now go to material properties, material models, structural, linear, elastic, isotropic. Specify the Young's modulus, which is 200 e power 3, and Poisson's ratio is 0.3. Click on OK. Then give the weight density, which is 7800 kg per meter cube. So 7800 e power minus 9. I'll convert that into newtons. So density is specified. You can see here density and all material properties are specified. Now we can go to sections, beam section, common section. We need to specify we can select the type of cross section given based on this. So in the given problem it is a square cross section, so I have selected square, and I will give the dimensions 10 by 10. Okay, now the dimensions are specified. You can start creating the model. So I'll go to modeling, create. So I'll create it through key points in active coordinate system. So key point 1, the coordinates 0, 0, apply. So key point 1 will be created. Now select key point 2. So x distance is 1000. So key point 2 is 1000, 0. So now key point 2 has been created here. So once you create a key point, we need to create lines. So I'll go to lines, straight line, select key point 1 and key point 2, click on OK. So now a straight line has been created. Once we create a model, we need to mesh the model. So I need to go to meshing, mesh tool, set the line, select this line, apply. So you can divide the element into as many divisions you want. I have selected 100 divisions. Okay, again go to mesh tool, mesh. I'll select pick all, so that command M which disappears, indicating that this line is totally meshed now. So after this step, so in order to give the loading parameters and other parameters, we need to go to solution. So this is a different case. So we'll go to solution. So here you can see analysis type. So keep observing these commands. After we give the new type of analysis, these commands will change. So new analysis. So now I'll select harmonic. You can keep observing this. So I'll select harmonic analysis. I'll click on OK. See, now we have different commands here. So I'll go to analysis options. So solution method is full, okay, and real plus imaginary, let this be as it is. Click on OK. And program chosen to solve this particular problem is a sparse solver. So I'll select the sparse solver, or you can select Jacobian, any method. So we are using the sparse solver, so we select sparse solver. Click on OK, and then go to load step options. Here select time and frequency, your frequency and substeps. So harmonic frequency range given in the problem is it is varying from 0 to 100. So I'll give 0 to 100. Number of substeps, you can give any number of substeps you need. So I'll give 100 substeps. So step by step 100 values. So I'm taking a stepped method of boundary conditions. Click on OK. Now go to define loads, apply, structural, displacement. So since we have created key points, I'll select on key points, select key point 1, apply, fix this in all degrees of freedom. Okay, now the constraints have been applied to this node, this key point, and force or moment again on key point. Now this key point 2 is subjected to harmonic force varying from 0 to 100 Hz, so it is in y direction, so it is acting downwards, so I'll select minus 100 Hz. Okay, so now you can see this is about applying loads, and now you can solve the problem. Go to solve, current LS. Okay, now the problem is solved, solution is done. Close this menu. And now, so usually throughout all the problems we used to, in order to see the solution output, we are going to general post processor. So in case of harmonic analysis, just go to, we need to have a harmonic plot. So for that sake, we'll go to time history post processor. So go to time history post processor. You can see a command menu like this. See, in this command menu, you can see add data command. So once it is open, just click on add data. So you'll get something like this. In this, go to nodal solution, DOF solution. Since the loading is in y direction, you select y component of displacement. So once you click on this y component of displacement, and if you click on OK, you will get a command menu like this, node for data. Okay, node for data. So you drag this down. Okay, so this is a node where the load is applied. I'll select this node, I'll select key point 2, click on OK. So now that key point is selected, and see, there is no graph is seen. So here you have another command called as graph data. You just click on graph data, so that harmonic frequency graph will be shown here. You can close this, and you can view this harmonic plot. Thank you.